Hello everyone, my name is Bharchini Ashwin Kumar. Today I am going to present my major project where I will be explaining my project on credit risk modeling, where I built a machine learning system that predicts whether a customer's loan should be approved or not. I will walk through every part of the project, including data loading, EDA, pre-processing, model training, and evaluation, and I will explain all the function I used in simple terms. Now, step 1 is importing libraries. The first step is importing all the Python libraries required for the project. Now, we have imported NumPy, Pandas, Matplotlib, Seaborn, Scikit-learn, different models. Now, NumPy helps with mathematical operation. Panda is used to load, view, and manipulate the dataset. Matplotlib and Seaborn are used to create graphs and visualization. Now, here that we have imported machine learning tools such as train test split, standard scalar, logistic regression, decision tree classifier, confusion matrix, accuracy score, classification report from the scikit-learn library. Here the train test split divides data into training and testing. Standard scalar is used to normalize numerical data. Logistic regression is the first ML model and the decision tree classifier is the second ML model we have used here. Confusion matrix, accuracy score, classification report are used to measure model performance. Step 2 is loading the dataset. To do that, we use readCSV function which simply reads the CSV file and loads it into a data frame called DF. Now, to the next step. To understand the dataset properly, I used a few basic commands here. df.head, which shows the first 5 rows of the dataset. df.shape, which shows total number of rows and columns. My dataset had 41,188 rows and 60 columns. df.describe, which shows statistics like maximum, minimum, mean, etc. df.info, which shows data types of each column and whether any values are missing. Here df.isNot.sum checks for missing values in each column. In my case, the data had no missing values, which was very helpful. Now, the next step is to do EDM. To understand patterns in the data visually, I performed exploratory data analysis here. Now, we first did age distribution through sns.eastplot df age carry true. Here, this graph shows the age spread of customers. Most customers were between 30 and 50 years. Now, we checked loan status distribution through sns.countplot x equal to loan status label data equal to df, where this shows how many customers got loan approval versus rejection. I found that the data is unbalanced, meaning more people were rejected than approved. Here, we also checked the correlation between features and the target through the correlation heatmap. This helps identify which factors influence loan approval the most. Step 5 is to prepare the data. I separated the dataset into features and target. Features are taken as x and the target are as taken as y. Here, x equal to df.drop columns loan status label. This takes all columns except the target, and y equal to df loan status label. This is the value we want the model to train. Now, in the next step, we split the data to the 80 to 20 ratios. Here, x train, x test, y test equal to train test split xy. Test size 0.2 is used to divide the data into 80% for training and 20% for testing. Training data teaches the model, while the testing data checks how well it performs on unseen values. Now, the next step is feature scaling. Scaling helps model work better by putting all values in similar ranges. Here we have used standard scalar. Now xtrain scaled equal to scalar dot fit transform xtrain, where fit transform calculates scaling values plus applies scaling. And here on the x test scaled equal to scalar dot transform x test is only applies the scaling learned earlier. Now to the next step, we we have used model logistic regression. Now the logistic regression is great for binary decision like loan approved or not. To make predictions, we use ypred IR equal to IR dot predict x state test scaled, and to check accuracy, we use IR dot score, where the results are for training accuracy 89.7% and for testing accuracy 89.8%. Now for the decision tree model, I set the max depth equal to 6 to keep the tree from becoming too deep and overfitting. Predict To predict the data here, we use ypred data equal to dt dot predict x test scaled, and the accuracy we got here is for training 90.2% and testing 89.7%, which is very decent. Now, the decision tree performs very similar to the logistic regression. We can actually see that here. The next step is to evaluate the models we have created. To do that, we use three evaluation tools which we imported earlier: confusion matrix, accuracy score, and classification report. Now, the confusion matrix is showing true positives, true negatives, false positives, and false negatives. Then accuracy score simply gives the percentage of correct predictions. Now the classification report gives precision, recall, and F1 score. Here both models struggle with predicting the minority class, which were approved loans due to dataset imbalance. To the next step, we compare the models we have used. Logistic regression and decision tree have accuracy of 89.7% and 90.2% respectively, while the testing accuracy is 89.8% and 89.7% respectively, which is identical almost. Here, the final insight we get is both models performed almost equally, where logistic regression is more stable and decision tree captures patterns slightly better. But the main issue we have here is class imbalance. We know that, right? To conclude, in this project, I successfully built a complete credit risk prediction model using machine learning. I worked with a dataset containing over 41,000 customers' records and 60 features. After performing detailed exploratory data analysis, I prepared the data by separating features and target, splitting into training and testing sets, and applying feature scaling. I trained two models, logistic regression and decision tree classifier, and for both, we nearly got 90% accuracy. Logistic regression performed more consistently, while decision tree captured patterns slightly better. However, both models struggled with minority class prediction due to imbalance in the dataset. Overall, this project demonstrates how data pre-processing, visualization, and machine learning algorithms can be used together to predict loan approval outcomes. The system can be further improved using techniques such as class balancing, hyperparameter tuning, or advanced models like XGBoost. This was my complete workflow for building a credit risk predicting system. Thank you for listening to me.